Part 2 of Grade 7 Olympiad Workbook, Chapter 13. Question number 11. What's the value of this expression? As a first step, let us take the base numbers 6, 35, 15, 14, 21 and 5 and write them down in terms of their factors. 6 to the power of 12 becomes 2 into 3 whole raised to 12. 35 to the power of 28 becomes 5 into 7 whole raised to 28. 15 to the power of 16 will become 3 into 5 whole raised to 16. In the denominator, 14 to the power of 12 becomes 2 into 7 whole raised to 12. 21 to the power of 11 will become 3 into 7 whole raised to 11. And let's keep the 5 to the power of 28 as it is. In the next step, let's expand the expression. 2 into 3 whole to the power of 12 will become 2 to the power of 12 into 3 to the power of 12. 5 into 7 whole to the power of 28 will become 5 to the power of 28 into 7 to the power of 28. And 3 into 5 whole to the power of 16 will become 3 to the power of 16 into 5 to the power of 16. In a similar manner, the denominator will become 2 to the power of 12 into 7 to the power of 12 into 3 to the power of 11 into 7 to the power of 11 into 5 to the power of 28. In the next step, we'll group the terms that have the same base value. 2 to the power of 12 in the numerator and 2 to the power of 12 in the denominator will get cancelled. Next, let's group the terms with base 3. We get 3 to the power of 12 into 3 to the power of 16 divided by 3 to the power of 11. That becomes 3 to the power of 12 plus 16 minus 11. Next, let's group the terms with a base 5. 5 to the power of 28 in the numerator and 5 to the power of 28 in the denominator will get cancelled. So we are left with 5 to the power of 16. Finally, we'll consider terms with the base of 7. 7 to the power of 28 in the numerator and 7 to the power of 12 into 7 to the power of 11 in the denominator will become 7 to the power of 28 minus of 12 plus 11. Simplifying this further, we get 3 to the power of 17 into 5 to the power of 16 into 7 to the power of 5. So our right option is option B. Next, question number 12. Let's find the value of a to the power of b minus b to the power of a if a is equal to 3 and b is equal to 7. First step, let's substitute the values for a and b. So we have 3 to the power of 7 minus 7 to the power of 3. 3 to the power of 7 is 3 multiplied 7 times and 7 to the power of 3 is 7 multiplied 3 times. For easier calculation, we can group and multiply. What we get is 2187 minus 343, which becomes 1844. So, our right option is option C. Next, question number 13. Let's find the value of this expression. Here, the first term, 3 to the power of 4 by 2 to the power of 3, looks simple when compared to the second term. So first, let's solve the second term. Here, the numerator 1 by 9 into 4, which is 4 by 9, can be also written as 2 square by 3 square. We do this step because all the other values in our expression are 3's and 2's. Now let's check the denominator. Here, the base is different, but the exponent is the same. So, we group the base together. What we get is minus 1 by 3 divided by 1 by minus 2, the whole raised to 3. Next step, let's simplify the numerator. 2 square by 3 square can be written as 2 by 3 the whole square. So our numerator becomes 2 by 3 the whole square, the whole raised to 2. Coming to the denominator. Here, let's change the division to multiplication and the following term to its reciprocal. What we get is minus 1 by 3 into minus 2 by 1 whole raised to 3. Next step, 3 to the power of 4 by 2 to the power of 3 is still kept as it is. The numerator of the second term becomes 2 by 3 whole to the power of 2 into 2, which is 4. And the denominator becomes 2 by 3 whole to the power of 3. In the next step, let's find the value of 3 to the power of 4 by 2 to the power of 3. That is 81 by 8. In the second term, the numerator and the denominator have the same base but different powers. So we can simplify that to 2 by 3 whole to the power of 4 minus 3, which is 2 by 3 itself. So our expression becomes 81 by 8 plus 2 by 3, which gives us the final answer of 259 by 24. So our right option is option B. Next, question number 14. A rectangular piece of land is to be sold off in smaller pieces. The total area of the land is 2 to the power of 17 square miles. The pieces to be cut out are 16 square miles in size. How many smaller pieces of the land can be sold at the given size? First step, let's write down what is given. Area of the total land in square miles is 2 to the power of 17. Area of the smaller pieces, again in square miles, is 16 square. For easier calculations, we'll change the 16 square to a number with a base of 2. 16 can be written as 2 to the power of 4. So 16 square becomes 2 to the power of 4 the whole square, which is 2 to the power of 4 into 2 or 2 to the power of 8. Now let's find what we are asked for. The number of smaller pieces of land. This is done by dividing the area of the total land by the area of the smaller pieces. So 2 to the power of 17 by 2 to the power of 8. That simplifies to 2 to the power of 17 minus 8, which is 2 to the power of 9. So our right option is option C. Next, question number 15. All the planets revolve around the Sun in elliptical orbits. Uranus's farthest distance from the Sun is approximately 3.004 into 10 to the power of 9 kilometers, and its closest distance is approximately 2.749 into 10 to the power of 9 kilometers. What is the average distance of Uranus from the Sun? First, let's note down the facts that are given. Farthest distance in kilometers is 3.004 into 10 to the power of 9, and the closest distance in kilometers is 2.749 into 10 to the power of 9. So, the average distance becomes the farthest distance plus the closest distance by 2. So, we have 3.004 into 10 to the power of 9 plus 2.749 into 10 to the power of 9 by 2. In this case, the two terms in the numerator have a product with 10 to the power of 9. So what we can do here is keep the 10 to the power of 9 as it is and add these two decimal values. What we get is 5.753 into 10 to the power of 9 by 2. So our result becomes 2.8765 into 10 to the power of 9. This shows us that the right option is option B. Next, question number 16. There are 3 places A, B and C in a straight line as shown below. If the distance between A and B is 2.4 into 10 to the power of 6 meters and the distance between B and C is 5.2 into 10 to the power of 5 meters, then find the distance between place A and C in standard form. First, let us note down what is given. Distance between A and B in meters is 2.4 into 10 to the power of 6. Distance between B and C in meters is 5.2 into 10 to the power of 5. And we are asked to find the distance between A and C, which is simply the sum of the above two values. But what we have to note carefully here is that one distance is given as a product with 10 to the power of 6 and the other distance is given with a product of 10 to the power of 5. In this case, it would be easier if both the exponents are same. Now let's take the distance between A and B. 2.4 into 10 to the power of 6. This 10 to the power of 6 can be written as 10 into 10 to the power of 5. Now let's multiply 2.4 and the 10. So we get 24 into 10 to the power of 5. Now addition becomes easier. We keep the 10 to the power of 5 as it is and add these two values. 24 plus 5.2 gives us 29.2. But we are asked for the answer in standard form. So we write 29.2 as 2.92 into 10. So our final answer becomes 2.92 into 10 to the power of 6, which gives us the right option of option B. Now we move on to question number 17. Mr. Gupta asked two of his students to solve this expression and write it on the blackboard. Aryan wrote the answer as 3 a to the power of minus 4 b to the power of 5, whereas Ayan wrote the answer as 3 b to the power of 5 by a to the power of 4. Who wrote the correct answer? First step, let's change the negative exponent to positive exponent. We do this by changing the base to its reciprocal. What we get is 81 a to the power of minus 5 b square by 9 a cube b to the power of minus 8 whole raised to half. Now let's simplify the base. 81 by 9 is 9. A to the power of minus 5 by a to the power of 3 becomes a to the power of minus 5 minus 3. And b to the power of 2 by b to the power of minus 8 becomes b to the power of 2 plus 8. This is equal to 9 a to the power of minus 8 b to the power of 10 the whole raised to 1 by 2. Now let's write 9 as 3 square. So our expression becomes 3 square a to the power of minus 8 b to the power of 10 the whole raised to 1 by 2. Simplifying that, we get 3 to the power of 2 into 1 by 2 into a to the power of minus 8 into 1 by 2 into b to the power of 10 into 1 by 2. That becomes 3 a to the power of minus 4 b to the power of 5. This is the answer given by Aryan. But let's wait and check if Ayan also has written the correct answer. The expression 3 a to the power of minus 4 b to the power of 5 can also be written as 3 b to the power of 5 by a to the power of 4, which was the answer written by Ayan. That means both Aryan and Ayan have given the correct answer. So our right option is option option C. Next, question number 18. Match the following. Let's consider the first statement P. 5 cube the whole square into 5 to the power of 5 divided by 5 to the power of 9. 5 cube the whole square becomes 5 to the power of 6. So we get 5 to the power of 6 into 5 to the power of 5 divided by 5 to the power of 9. That simplifies to 5 to the power of 6 plus 5 minus 9, which is 5 to the power of 2 or 25. So statement P will match with answer 4. If you look at the options that are given, we can find that P matches with 4 only in options C and D. So options A and B can be ruled out. Now let's go ahead and solve statement Q. Minus 6 whole to the power of 5 divided by 6 square. Here in the base we have a negative number and the exponent is an odd number, which means the negative sign will be retained. So what we get is minus of 6 to the power of 5 divided by 6 square. We keep the minus as it is and simplify to 6 to the power of 5 minus 2, which is minus 6 to the power of 3. Again, since the exponent is an odd number, this can also be written as minus 6 whole to the power of 3. That means statement Q matches with option 1. This pair is available only in option C. So even before finding out the answers for the other statements, we can confirm that the right option for this question is option C. But still, we'll find the answers for the other statements as well. Statement R. Here, let's remember that any number raised to the power of 0 will always be 1. 1 to the power of 0 plus 2 to the power of 0 plus 3 to the power of 0 becomes 1 plus 1 plus 1. 10 to the power of 0 is also 1. 5 to the power of 0 is 1. 4 to the power of 0 plus 6 to the power of 0 by 2 to the power of 0 becomes 1 plus 1 by 1. That simplifies to 3 into 1 plus 1 into 2 by 1. According to the order of operations, we'll do the multiplication and division before the addition. So what we get is 3 plus 2, that is 5. So R matches with option 2. Finally, we'll consider statement S. Minus 1 by 3 whole raised to 12 divided by minus 1 by 9 whole raised to 5. In the first term, the exponent is an even number. So, the answer becomes positive. That gives us 1 by 3 whole raised to 12. But in the second term, the exponent is an odd number. So, the negative sign will be retained. What results is minus of 1 by 9 whole raised to 5. To make our calculations easier, let's keep the negative sign outside our expression. What results is minus of 1 by 3 whole to the power of 12 divided by 1 by 9 whole raised to 5. Let's write the 9 as 3 square. We get minus of 1 by 3 whole raised to 12 divided by 1 by 3 square whole raised to 5. The second term simplifies to 1 by 3 to the power of 2 into 5, which is 1 by 3 whole raised to 10. In this expression, our base of the two terms remains the same. So, we subtract the exponents. We get minus of 1 by 3 whole to the power of 12 minus 10, which is minus 1 by 3 square. This means that the statement S will match with option 3. So we can confirm that the right option is option C. Next, question number 19. Which of the following statements is true? We are given two statements here. So let's go ahead and find out which of them are true. First statement. If x is equal to 2 by 3 whole raised to 4 divided by 2 by 3 whole raised to 2, then the value of x square plus 2x plus 3 is 0. First, let us find the value for x. X is equal to 2 by 3 whole raised to 4 divided by 2 by 3 whole raised to 2. That is equal to 2 by 3 whole raised to 4 minus 2, or 2 by 3 the whole square, which is 4 by 9. Now let's substitute this value of x in the expression x square plus 2x plus 3. What we get is 16 by 81 plus 8 by 9 plus 3. The LCM of the denominator is 81, and in the numerator we get 16 plus 72 plus 243. That simplifies to 331 by 81. But statement 1 says that the value of this expression should be 0. So clearly statement 1 is false. Let's move on to statement 2. If minus 1 by 2 whole raised to 4 into minus 2 whole raised to 8 is equal to minus 2 whole raised to 4x, then x is equal to 1. First step, let's write the equation as it is. All the terms in our equation have a base which is negative, but the exponents 4, 8 and 4x are all even numbers. This means the answer is positive. So, the negative sign can be ignored. So, our equation will become 1 by 2 to the power of 4 into 2 to the power of 8 is equal to 2 to the power of 4x. Simplifying, we get 2 to the power of 8 minus 4 is equal to 2 to the power of 4x. which is nothing but 2 to the power of 4 is equal to 2 to the power of 4x. Here, since the base in both the left side and the right side of the equation is the same, we can equate the exponents. So 4x is equal to 4, which means that x is equal to 1. So statement 2 is true. That means the right option is option B. Next, question number 20. Here we find if the given statements are true or false. First, statement B. If x and y are non-zero rational numbers and m is a positive integer, then let us find out if the given two equations are true. First, x to the power of m into y to the power of m. Here, the exponent remains the same, but the base is different. So we keep the exponent as it is and multiply the base. What we should get is x into y whole raised to m. But the statement given shows that it is x into y whole to the power of 2m, which is false. Also, x to the power of m divided by y to the power of m becomes x by y whole to the power of m. But in our question, it is given as x by y whole to the power of 1, which is again false. This means that statement P can be marked as F. P is marked as F only in options B and C. So options A and D can be eliminated. Also, in options B and C, we can find that the statement Q is always true. So, instead of finding out statement Q, we can try to answer R or S so that we'll arrive at the correct option. Let's find out option R. The base and power in minus 16 into 2, the whole raised to 4 is minus 32 and 4 respectively. Here, minus 16 into 2 is minus 32. So the base is minus 32 and the power is 4. This shows that statement R is true. So out of the given two options B and C, we can confirm that option B is the right answer. But still, we'll go ahead and find out if the statement S is true or false. 6 to the power of 2 is greater than 2 to the power of 6. 6 to the power of 2 is 36 and 2 to the power of 6 is 64. Now, 36 is not greater than 64. So this means that statement S is false. This again confirms that the right option is option B. With that, we come to the end of the session. If you found this video to be helpful for your Olympiad preparation, give it a like and share it with your friends. Thanks for watching.